All right, guys, we're going to look to find the first five terms of the Maclaurin expansion of f of x equals e to the x cosine x. In previous problems, we would write f and then f prime, f double prime, and so on, and then evaluate at x equals 0. That's going to end up being a lot of extra work, especially if you already know the expansion of e to the x and of cosine x, which we do. It's very typical on the AP exam that some of your basic or expected to be known expansions will be used, and you're supposed to apply those to other seemingly more complex problems. And you'll see that is one of those are really what's happening in some of the problems in today's assignment. So the very first thing we're going to do, we're going to use the knowledge we already have about the expansion of e to the x and about the expansion of cosine of x. Right? So I'm going to write the expansion of e to the x. And of course, I'll use my ellipsis so that I don't have too much going on here. So I've got 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot, 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 right? That's my expansion of e to the x. Now, if I'm also expanding cosine of x, I know that one as well, right? So you guys did that yesterday for your assignment. I actually expanded a Taylor expansion of cosine x at pi over 2 today. So we have those at the ready. That's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus, and I'll say x to the 6th over 6 factorial plus dot, 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 and it goes on and on and on forever, right? So this is the expansion. But if we're writing the first 5 terms, we actually have to multiply those out, right? You probably remember something often referred to as like foiling, right? We're going to do something very similar to that, except that only works when it's a binomial times a binomial. So we're gonna use, it's still the same idea of foiling, but we've kind of cleaned it up to be something that's much more useful. And so what we'll do is we'll take this part, and this is truly what happens. This first term will actually get distributed to this entire series. So we'll have 1, right? We'll have 1 times that whole thing, right? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus, I'm just going to put dot, dot, dot. There we go, right? The next piece, this is a plus x, right? So it'll be plus x times the whole thing, right? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus dot, 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 right? That's the first 2 terms, right? I want to go to the third. All right, here we go. So we're looking at the third term. We're going to take this guy right here. So x squared over 2 factorial times that whole thing. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus dot, 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 right? 1, 2, 3. We've got 2 more to do, right? 2 more to do because we're supposed to have the first five terms, right? So here we go. Right there. That'll be, and I'm going to write it down here on the next line. So that's x cubed over 3 factorial. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus dot, 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 right? And we've got one last one to do, right? One more. So last one, we're going to take this guy, and this will be 1, 2, 3, 4, 5 terms. So that's plus x to the fourth over 4 factorial, again, times 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus ... right? So those are our first 5 terms. If we were to distribute, right, we're going to start distributing and kind of clean all of this stuff up, right? This first one right here, the first term, when we took 1 and distributed it to all those terms, we'd end up with 1 minus x squared over 2 plus x to the fourth over 24. Now, why does that happen, right? Why does it stop there? Take a minute and see if you can figure that out. Well, if you have figured it out, it's kind of forethought, right? We're noticing that since it's going to be the first 5 terms, we are going to have a constant term, probably have a first degree term, second degree term, third degree term, fourth degree term, and so on. So if we need the first 5 terms, we'll see. Hopefully, by stopping under a degree of 6, we'll have done enough. If that doesn't make sense yet, hopefully it will once we work through some more of these. The next piece, when I distribute that x in, I'll have x minus x cubed over 2 plus x to the fifth over 24. Again, I'm stopping there because the next term would have been x to the seventh. Of course, it's not that it doesn't exist, but I'm stopping because of the instructions here, right? I'm not expanding the entire thing. I'm only finding the first 5 terms, right? When I put this guy in, this x squared over 2 factorial, my first term would be x squared over 2 factorial, right? X squared over 2 factorial, or just plain x squared over 2, minus x to the fourth over 4. And then the next term would be larger than what I'm dealing with, right? Next one, when I bring in x cubed over 3 factorial, I'll have x cubed over 6 minus x to the fifth over 12. Again, I'm stopping there only because I know what happens after that. The degree will likely be too large. And then the last one, when I'm bringing in x to the fourth over 4 factorial, I'll have x to the fourth over 24 plus x to the fifth over 120, right? Of course, that keeps going forever, right? So I could put plus ... And I'm going to clean this whole thing up a little bit. All right, and I'll get rid of the colors at this point. So I've got 1 plus, well, let's see, there's an x plus, let's see, how many x squareds? I've got an x squared there, an x squared there. So I'll have negative 1/2 plus 1/2, right? So it's negative x squared over 2 plus x squared over 2. Of course, that ends up going away completely, but I'm going to write it this way so we can kind of see how everything's coming together. It allows us to process some of this stuff a little faster by just writing out the coefficients as a sum or difference out in front, right? So there's x to the fourth. And then, of course, our last little bit, 1/24 plus, whoops, that's a minus. So I'll just say plus a negative 1/12 plus 1/120th, and that's all x to the fifth. And we're going to keep going forever, right? So what does that equal? 1 plus x, let's see, that would be minus 1/3 x to the third minus, we'll put all this stuff together. Let's see, that would be 1/6 x to the fourth. And then the last one, when we put all this stuff together, let's see, we end up with negative 1/30 x to the 5th. So let's see, the first 5 terms, first 1, 2, 3, 4, 5, there it is. So we've got our first 5 non-zero terms of the Maclaurin expansion.